Let us discuss about reliability design using dynamic programming. Let us solve this problem. Design a three-stage system with device types D1, D2, D3. The costs are 30, 15, 20. The cost of the system is to be no more than 105. The reliability of each device type is 0.9, 0.8, 0.5. So for this we have to design a system. So here totally 3 devices are given. So here DA represents devices. Totally we have 3 devices. And the cost of devices are 30, 15, 20. So C1 means 30, C2 15, C3 20. So the second column CI represent cost. So the cost of the first device is 30, second device 15, third device 20. And the reliabilities are 0.9, 0.8, 0.5. So R1 equal to 0.9, R2 equal to 0.8, R3 equal to 0.5. So 0.9, 0.8, 0.5. So here the problem is there is a possibility that a device may fail. Assumes, let us take the example of a marker pen. So there may be a possibility that the ink in the marker pen may be over. So that's why instead of maintaining a single device, if we maintain multiple devices, so multiple copies of the devices, then if one device fails, then we can work with another device. So let us take the example of the marker pen. Instead of maintaining one marker pen, if we maintain multiple marker pens, then if one marker pen failed, that means if the ink is over, then we can use of the second marker pen. So here that is the problem here. So instead of maintaining one device, let us maintain multiple devices. So here we have to maintain multiple devices of D1, multiple copies of D2, multiple copies of D3. So in order to determine the maximum copies, here we are calculating the upper bound. So to calculate upper bound of each device or stage, we are using this formula. So with the help of the formula, we can maintain multiple copies of a device. So here the formula is UI equal to floor of. So we know about seal and floor. So seal means it will give the highest value. Floor means it will give the least value. So floor of 3.3 means, so floor means it will give minimum value 3. Whereas seal of 3.3 means it will give maximum value, that is 4. So floor of C plus EI minus sigma j is equal to 1 to n Cj. So Cj means j value starts from 1 to that device. So costs of the devices by, so here one more thing is given. The cost of the system is to be no more than 105. So the cost of the system is, it should not be more than 105. So for that purpose we have taken C. So C is equal to 105. 105. So that is nothing but that C by Ci. So first let us calculate U1. So U1 equal to floor of, what is C value? C value is 105. So 105 plus. So first we are calculating for the first device. So for the first device, what is the cost? Cost of the first device is 30. So 30 minus, here it is a summation of C1, C2, C3. So C1 plus C2 plus C3 by, what is the cost of the first device? 30. So that is equal to 105 plus 30 means 135. So 135 minus C1, C2, C3 values are 13, 15, 20. By, what is the cost of the first device? That is 30. That is equal to 135 minus 30 plus 20, 15 plus 20 means 30 plus 20 means 50, 50 plus 15 means 65. 65. So 135 minus 65 means 70. So 135 minus 65 means 70. So 70 by 30. So 70 by 30 means we will get 2 point something. But floor means, floor of 2 point something means it will give 2 as the result. So here U1 value is 2. So maximum we can take 2 copies of device 1. Maximum we can maintain 2 copies of device 1. Likewise calculate U2. U2 equal to floor of 105 plus here cost of the second device. Cost of the second device is 15. So 15 minus same values, we have to add them. So we'll get 65. So 105 plus 15 means 110. 105 plus 15 means 120. So 120 minus 65 means 55. So 55 by, what is the cost of the second device? The cost of the second device is 15. So 55 by 15 means we will get 3 point something. So that is equal to floor means 3. So maximum we can maintain 3 copies of device 2. So likewise floor of 105 plus cost of the third device is 20. So 20 minus 65 by 20. So 105 plus 20 means 135. So 135 minus 65 means 60. So 60 by 20 means 3. So maximum we can maintain 3 copies of the third device. Now we have to consider S power I j, where I represents stage number. Here we have 3 stages. Stage 1, stage 2, stage 3. Stage 1 means device 1. Stage 2 means device 2. Stage 3 means device 3. Where here j represents number of copies. So in stage 1 maximum we can maintain 2 copies. In stage 2 maximum we can have 3 copies. Likewise, if we consider S power 2 3, so it means stage 2, that means device 2, and we have 3 copies. So initially we have to calculate, we have to consider S power 0. S power 0 equal to, it contains an ordered pair. First one is reliability, second one is cost. The maximum reliability is 1, whereas we have to take the initial cost, that is 0. So first consider stage 1 or consider device 1. So here in stage 1 maximum we have 2 copies. So upper bound here is 2. So U1 is equal to 2. Here this one specifies device 1 or stage 1. So here we have to calculate S power 1. So here the formula is, here power 1, this 1 means device 1 or stage 1. Stage 1 is equal to S power 1. So stage 1, here maximum we have 2 copies. So that means either 1 copy or 2 copy. So 1. So S power 1 1. So this 1 means 1 copy. Union S power 1. So that means first device, first stage. So this 2 specifies 2 copies. So here we have to calculate S power 1 1, S power 1 2. So here first we have to calculate S power 1 1. Here in S power 1 1, so what is M1 value? So here M1 means number of copies. So here the number of copies are, so how many copies here? Here we have 1 copy, S power 1 1. So this one is nothing but number of copies, M1 equal to 1. Here in order to calculate the probability, the formula is 1 minus, within the parenthesis 1 minus, here first device, so we have to consider reliability 1 whole power M1. So M1 means number of copies of the first device. So that is equal to 1 minus, what is first device reliability? That is 0.9. So 0.9 whole power. So initially we are calculating S power 1, 1. So M1 value is 1, whole power 1. So 1 minus 0.9 means 0.1. 0.1 whole power 1 minus, so here this 1 minus 0.9 is nothing but 0.1. 0.1 whole power 1 is nothing but 0.1. So 1 minus 0.1 is nothing but 0.9. So now the reliability here is 0.9. So initially we are calculating the reliability. Reliability if the device is not having any errors. So the reliability is 0.9 comma. Here what is the cost of the first device? Here in the pair, the first one is reliability, the second one is cost. Now we got reliability as 0.9. What is the cost of device 1? So this is first device. Cost of the first device is 30. Here how many copies we have? Here we are maintaining only 1 copy. So that's why here we have taken only 30. So this 30 means cost of the first device. That is, we got 0.9 comma 30. Now here what will happen is stage 1 output will be given as input to the stage 2. So that's why every time what we have to do is, after getting a stage output, we have to do some multiplication and addition with its previous stage output. What is S power 0? 1 comma 0. So this 1 is nothing but reliability. So we have to multiply the reliabilities. This 0 is nothing but cost. and we have to add the cost. So here what is the reliability we got? 1 in s power 0, 1. Now here the reliability is 1. So multiply 0.9 and 1 comma, and we need to add the cost. So 30 plus 0. So 0.9 into 1 means 0.9 comma 30 plus 0 means 30. So next we have to calculate s power 1 2, s power 1 2. So here what is m1 value? Here we are maintaining 2 copies. So m1 value is 2. So now we need to calculate the reliability. So for that the formula is 1 minus, within the parenthesis 1 minus R1 whole power m1. So 1 minus what is R1? R1 is 0.9 only. 0.9. Here what is m1? Here we are maintaining 2 copies. Now we have 2 copies. So here we have 1 copy, here we have 2 copies. So that is equal to 1 minus. So 1 minus 0.9 means 0.1. So 0.1 square means 0.01. So 1 minus 0.01 means 0.099. So now what is the reliability? 0.99 is the reliability. Here what is the cost of the first device? 30. But here how many copies we have? Here we have 2 copies. So 2 copies. So 2 copies means 30 plus 30 or 30 into 2. Here we have 2 copies of the device 1. So 30 plus 30 means 60. So now the pair is 0.99 comma 60. Now what we have to do? We have to do multiplication with its previous stage. We have to multiply the reliabilities and add the cost. So 0.99 into 1 comma 60 plus 0. 60 plus 0 is nothing but 60. Now we have to calculate s power 1. What is s power 1? Simply we have to add the corresponding pairs. So s power 1 equal to, so now the formula is, so what is s power 1? S power 1 equal to, we got s power 1 1, that is nothing but 0.9 comma 30. And what is s power 1 2? That is 0.9960. So now stage 1 is calculated. So likewise we have to calculate stage 2 as well as stage 3 reliabilities and cost. Now let's see stage 2, or consider the second device, that is D2. Here the upper bound value is U2 equal to 3. So maximum we can take 3 copies. So s power 2 equal to, so this 2 specifies stage number 2, that is equal to s power 2 1 union s power 2 2 union s power 2 3. So now we have to calculate these 3. So s power 2 1. So here the number of copies. So previously in device 1 we have taken m1, whereas in the second stage m2, in the third stage m3. So m2 equal to, here the number of copies are 1. Now let's see how to calculate the reliability. We know the formula. So 1 minus, within the parenthesis 1 minus, so this is second device, so R2 whole power m2. So that is equal to 1 minus, here R2 value is 0.8 whole power, here the number of copies are 1 in the here whole power 1, that is equal to 1 minus 0.8 means 0.2. So 0.2 power 1 is nothing but 0.2, that is equal to 0.8. So 0.8 comma, here the cost of the second device is 15. So how many copies we have? Only 1 copy. So 15 into 1, that is equal to 15. But here we have to multiply this S2 information with S1 information. What is S1? 0.9 comma 30 comma 0.99 comma 60. So multiply the reliability and add the cost. So 0.8 into 0.9 comma 15 plus 30 comma 0.8 into 0.99 comma 15 plus 60. So that is equal to, if you do the multiplication, we will get 0.72. 15 plus 30 means 45 comma 0.8 into 0.99 means 0.792. 50 plus 60 means 75. So this is the result of s power 2 1. Likewise compute s power 2 2. So here the number of copies are m2 equal to 2. Now let us calculate the reliability. So 1 minus, within the parenthesis, 1 minus R2 whole power m2. So 1 minus 0.8, here m2 value is 2, number of copies are 2. So 1 minus 0.8 means 0.2, 0.2 square means 0.04. So 1 minus 0.04 means 0.96. So 0.96 comma, what is the cost of the second device? Cost of the second device is 15, but here we have 2 copies. So 15 into 2, that is equal to 30. So here the order pair is 0.96 comma 30. Now we have to multiply this information with its previous stage information, that is s power 1. So every time we have to do with previous stage information. In s power 3 we have to do the multiplication and addition with s power 2. So here 0.96 into what is s power 1 information? 0.9 comma, here the cost is 30, so 30 plus 30 comma 0.96 into 0.99 comma 30 plus 60. So if we do these multiplications, we will get 0.864 comma 30 plus 30 means 60 comma, if we do this multiplication we will get 0.9504, 30 plus 60 means 90. Likewise we have to compute s power 2 3. Here M2 value is number of copies are 3. Now let us calculate reliability. 1 minus R2 whole power M2. So 1 minus reliability is 0.8 second device whole power. Here M2 value is number of copies are 3. So 3. So 1 minus 0.2, 1 minus 0.8 means 0.2. 0.2 whole cube means 0.008. So 1 minus 0.008 means 0.992. So 0.992 comma, cost of the second device is 15. But here we have 3 copies. So 15 into 3 means 45. So 45. Now we have to do multiplication and addition with its previous stage, that is s power 1. So 0.992 into 0.9 comma 45 plus 30 comma 0.992 into 0.99 comma 45 plus 30, 45 plus 60. So if you do the multiplication, we will get 0.8928 comma 45 plus 30 means 75. So if you do the multiplication, we will get this value. 45 plus 60 means 105. So here the cost of the entire system is 105. But here we got 105. So in the previous stage, we need to add third device cost also, that is 20 also. So if we add the third device cost, then we will get 105 plus 20, 135. So which is beyond the cost of the system. So we have to remove this ordered pair. So put cross mark here. Now we have to calculate s power 2. What is the formula for s power 2? So here I don't have any space. So that's why I am writing here. So s power 2 1 union s power 2 2 union s power 2 2. Here while writing the ordered pairs, we have to arrange them in ascending order based upon the reliability. So here the minimum reliability is 0.72. So 0.72 comma 45. Next to maximum is 0.792 comma 75. Next to maximum is 0.864 comma 60. We have to arrange them in ascending order based upon the reliability. Next value is this one, 0.8928 comma 75. Next there is no need to write this one. Why? Because here the cost is 105. So remove this pair. Next we have 0.9504 comma 90. Next if we see here, if we consider any ordered pair, then we have to follow some constraints. If the reliabilities are in ascending order, then the cost should also be in ascending order. This is called as pruning rule. Here the reliabilities are in ascending order and the costs are also in ascending order. So we can maintain those two pairs. Let us consider second and third pair. Here the reliabilities are in ascending order, but what about cost? 75, 60. So these two are not in ascending order. So we have to remove this pair. So we have to put the cross mark. So we have to remove this pair. Next, let us consider these two. 0.864, 0.8928 ascending order. 60, 75 ascending order. Next 0.8928, 0.9504 ascending, 75, 90 ascending order. But if we consider the last pair, here the cost is 90, whereas the cost of the third device is 20. So 90 plus 20 means 120. 90 plus 20 means 110. But here the cost of the entire system is 105. So this pair is not possible here. So we have to remove this pair also. Why? Because at the second stage only we got the cost as 90. At the third stage minimum, if we add one device cost, we will get 110. 90 plus 20, that is third device cost, 110. But the cost of the entire system is 105 only. So here now s power 2 contains only, so this pair and this pair, it contains only 3 pairs. So based on that we have to calculate s power 3. Now let us consider stage 3 or device 3. Here the upper bound for the third device is 3. So we have to calculate s power 3 is equal to third device s power 3 1 union s power 3 2 s power 3 3. So maximum we can have 3 copies. So first let us find out s power 3 1. So that means m3 equal to 1. So 1 copy. So for the reliability the formula is 1 minus R3. Why? Because this is third device whole power m3. So 1 minus reliability of the third device is 0.5. So whole power m3 means number of copies. Here the number of copies are 1. So 1 minus 0.5 means 0.5. 0.5 power 1 means 0.5. So 1 minus 0.5 means 0.5. So 0.5 comma. The cost of the third device is 20. Here we are maintaining only 1 copy. So 0.5 comma 20. Now we have to multiply this reliability with its previous stage information such as s power 2. Now we are calculating s power 3. So what is the reliability here? 0.5 into, here the reliability is 0.72 comma 20 plus 45. We have to add the cost comma. Next 0.5 into 0.864 comma 20 plus 60. If you do the multiplication we will get 0.36. 20 plus 45 means 65. If you do the multiplication we will get 0.432. 20 plus 60 means 80. If we do the multiplication we will get 0.4464. 20 plus 75 means 95. So here all the pairs are in proper format only. So there is no need of any pruning. There is no need of any removing. Next calculate s power 3 2. So here the number of copies are 2. Same. For reliability the formula is 1 minus R3 whole power m3. So here 1 minus R3 means 0.5. So 1 minus 0.5 means 0.5. Power number of copies are 2. So 0.5 whole square means 0.25. 1 minus 0.25 means 0.75. So 0.75 comma. Here we are maintaining 2 copies. So 20 into 2 that is equal to 40. So now we have to multiply and add with the previous stage information. So 0.75 into 0.72 comma 40 plus 45 comma 0.75 into 0.864 comma 40 plus 60 comma next 0.75 into 0.8928 comma 40 plus 75. So here we have 40 plus 75. So 40 plus 75 means 115, but the maximum cost of the system is 105. So we have to remove this pair. So next we will get 0.75 into 0.72 means 0.54. 40 plus 45 means 85 comma. If we do this multiplication we will get 0.648 comma 40 plus 60 means 100. So we have to remove this pair. Likewise calculate s power 3 3. m3 equal to 3. So 1 minus R3 whole power m3. So 1 minus R3 means 0.5. So 1 minus 0.5 means 0.5. So 0.5 whole cube means 0.125. So 1 minus 0.125 means 0.875. Here the cost of the device is, third device is 20. Here we are maintaining 3 copies. So 20 into 3 means 60. Now we have to multiply and add with its second device. So 0.875 into 0.72 comma 60 plus 45. Next comma 0.875 into 0.864 comma 60 plus 60. Next pair also 75 plus 60. So 75 plus 60 means 135, but here the cost is 105. So we can remove this one. 60 plus 60 means 120, but the cost is 105. So we can remove this pair also. So 0.875 into 0.72 means 0.63 comma 60 plus 45 means 105. Now we have to compute s power 3. The formula for s power 3 is s power 1 3 union s power 3 2 s power 3 3. So what is s power 3 1? 0.3665. Arrange them in ascending order based on the reliability. So 3665. Next 43280. Next 446495. So next one 5485. So if we observe these two, so this is in ascending, this value will comes first. So 0.63 comma 105 comma 0.648 comma 100. If we observe the first two pairs, so the reliability is in ascending order as well as cost is also in ascending order. Next, if we observe these two pairs, reliability is in ascending order, cost is also in ascending order. If we observe these two pairs, reliability is in ascending order, but what about the cost? 95, 85. So they are not in ascending order. So we have to remove this pair. So there is no need of 0.446495. So if you observe these two, 5463, 85, 105. If you observe these two, so reliability is in ascending order. But what about cost? 105, 100. They are not in ascending order. So remove this pair. So we have to remove these two pairs. So 0.36 comma 65 comma 0.432 comma 80 comma, we have to remove this one, 0.54 comma 85 comma 0. What is the pair? So which pair we have to remove? Yeah, we have to remove this pair, not this pair. So 105. So this here the cost is more cost. Okay. So we have to remove this pair. So keep this pair, 0.648 comma 100. So this is about S power 1, S power 2, S power 3 data stage. So in S power 3, the highest reliability pair is this one, 0.648. So we have to consider that pair, 0.648 comma 100. That is the high reliability pair. Now in order to trace the solution, that means how many copies of each device we have to purchase or we have to maintain, we have to consider this high reliability pair. This 0.648 is belongs to S power 3, 3. 0.648 is belongs to S power 3, 2. S power 3, 2. So that means we have to maintain 2 copies of the third device. Now how we got 0.648? So we got 0.648 from this pair, that is from 0.864. So from this pair we got that information by multiplying with the corresponding data. We got this pair, this 0.86460. So this pair is belonging to S power 2, 2. So that means we have to maintain 2 copies here. We have to maintain 2 copies of the second device. So M2 equal to 2. So now how we got 0.864? So we got 0.864 by multiplying with this pair, 0.9. So 0.9 comma 30 is belonging to S power 1, 1. So now M1, what is M1 value? M1 value equal to 1. So 1 copy of the first device, 2 copies of the second device, next 2 copies of the third device we have to purchase or maintain. So this is about reliability design using dynamic